Hello everyone. We have a calculus question today. So suppose y equals 3x minus 7 is the equation of the tangent line at x equals 2 for y equals 1/3 ax cubed plus bx squared. Find the values of a and b. Alright, so we start off by drawing out what the function 1/3 ax cubed plus bx squared might look like, which is the graph that you see in black. So it's kind of like maybe just a generic cubic function that a lot of these look like. And again, this is not, I'm not saying that's what it looks like, but it might look something like this. And I'm just, the reason for the drawing is just to get a couple points across that I think they're easier to see if you visualize them, okay? Then in blue we have the tangent line of 3x minus 7, and it's tangent at x equals 2, so it basically just touches it at x equals 2. And what I want to notice here is two pieces of information that we get, okay? Notice that the y value at x equals 2 is the same for y equals 1/3 ax cubed plus bx squared and y equals 3x minus 7. When you have a line that's tangent to a graph, the line touches the point and they share the same y value here, okay? And what can I do with that information? Well, let's see what we can do with that. We can go ahead and find the y value from the line at x equals 2, which would be 3 times 2 minus 7. So 3 times 2 is 6, minus 7 minus 1. And that's what the y value of your graph has to be as well at x equals 2. So you have minus 1 equals 1/3 a times 2 to the third plus b times 2 squared. Okay? And you get minus 1 equals 8/3 a plus 4b. So we have an equation here. Great. But the issue is I've got two variables that I need to solve for, a and b. So two variables means two equations. So that's one. The next thing I want to do is this. Well, remember, what's a tangent line referring to? It refers to a derivative. And the derivative at x equals 2 for this function is the slope of the tangent line. So at x equals 2, the slope of the tangent line would be 3. Why? Because the tangent line is 3x minus 7. That line has a slope of 3. And therefore, the derivative for your function at 2 is going to be 3. So let me state that. So here's the other point here, that since y equals 3x minus 7 is the equation of the tangent line, and the slope of this line is 3, then the derivative of 1/3 ax cubed plus bx squared at x equals 2 must be 3 as well. Okay, so again, that's just reiterating what it means to see what a slope of a tangent line is. It means the derivative at a particular point is equal to that value. So that slope of that line is 3, therefore the derivative of the function at 2 must be 3 as well. So I'm going to take the derivative dy dx or y prime, whichever you prefer. Let me start off with that first. So dy dx would be ax squared plus 2bx, so just applying the power rule here. And I am going to now replace my x's with 2. So you would get 4a plus 4b. And all of that has to equal 3. So now we have two equations. We have 4a plus 4b equals 3. And then, let me go back over here. We had minus 1 equals 8/3 a plus 4b. Okay, so we have two equations, and I'm going to just rewrite the second equation. Just put the 3 on the other side. So you have a system of two equations for which we need to solve, okay? And how do we go about doing this? Well, what you can do is you can multiply an equation by a constant and then add it to the other one. So I'm using the elimination method here. So I'm gonna take the first equation, multiply that by -1, and that would result in 1 equals minus 8/3 a minus 4b. And I'm going to keep the second equation the same here. And the reason I did that was so when we now add these two equations together, the b's go away. 1 and 3 add up to give you 4. Minus 8/3 a plus 4a give you a 4/3 a, getting a common denominator. And yeah, let's get rid of that fraction. I'm going to multiply both sides by 3. 4a would equal 12. So that means that a equals 3. So you have a equals 3, and then you just need to find b. And what you can do is you can just take what you just found and put it into one of the equations we have. So 3 equals 4a, which is 4 times 3 plus 4b. So you get 3 equals 12 plus 4b. 4b equals minus 9. So b equals minus 9/4. Okay. And there you go. So your equation, or your function, would be 1/3 a, so 1/3 times 3 x cubed plus minus 9/4 x squared. Okay. And simplifying a little more, it gives you x cubed minus 9/4 x squared. So that would be your function that has those desired properties. Okay. So just to reiterate what we did, we got two pieces of information from knowing that a line was tangent to a function at a particular point. The first point was the y value is always shared by the tangent line at the function at the point of tangency at x equals 2. So we plugged 2 into our line to get what the y value would be, which is the y value that has to be in the function to share it. And then we said, well, 3x minus 7 is the equation of the tangent line. So the slope of that line 3 is equal to the derivative of the function at 2, because that's what it means to, to be the slope of the tangent line, okay? So we took the derivative of our function and we plugged 2 into that, and it has to be equal to 3. And then we had a system of equations. So often with these problems, when you're asked to find a, b, or c, or whatever number of variables you're asked to, you're going to need that number of equations. So we had 2 variables to find, and we needed 2 equations. Then we solved this by using the elimination method. And let me just write that out real quick. And basically that method just consists of you multiplying an equation, or 2, it could be 2, by an appropriate constant, then adding the equations together so one of the variables cancels like we did here. And then we solved, and that was it. We didn't really have to write what the equation was, but just wanted to put in all the numbers. And if you want to reference this, you want to graph this yourself and see how this works, go ahead and do so. Okay. Thank you so much for your time, and I hope this helps.